Alright, so this is Chapter 8, Chemical Bonding. When two atoms come together and stick together, their portion that makes them stick together is known as a bond. There are three kinds of bonds that we will look at in this chapter. One of them is called an ionic bond. Ionic bonds are where electrons aren't shared very well, they're transferred. And so the electrons right here are given from one atom to another. Covalent bonds, where we have electrons that are shared very nicely, maybe unequally, but they're shared between the two. And this line or this dash in between means that there's two electrons right here and they're being shared back and forth between the atoms. And then the last one is called a metallic bond. And this is usually delocalized electrons where lots of electrons are around being shared by many, many different atoms throughout the metallic structure. All right, to symbolize bonding, we use what are called Lewis electron symbols or Lewis dot structures. And in section 8.1, it's called Lewis symbols and the octet or the duet rules. So Lewis dot structures are the symbol of the element and then dots to indicate its valence electrons. And so I use chlorine as an example right here because chlorine's in group 17. That means chlorine has 7 valence electrons. Remember, group 16 has 6, 16 has 6, 15 has 5, 14 has 4, 13 has 3. So this group would have 7. Group 18, of course, would have 8. And so you put 7 dots around the symbol of the chlorine. And where you put the dots doesn't make a whole lot of difference as long as there's 7 of them. It's customary to put the dots where there's 2 on each side, but as long as it adds up to 7, 2, 4, 6, 7, that's where it really matters. So I've got to make sure I got 8 dots, 7 dots right here. That would be the Lewis dot structure for chlorine. Let's take a look at a few other Lewis dot structures. Sodium right here would have 1 valence electron because it's in group 1, so it would look like that. Magnesium, 2 dots. Aluminum, 3 dots because it's in group 13. And then you can see that they go on here for silicon, phosphorus, sulfur, and chlorine. And then argon, of course, has 8 dots around it as well. But when you see these Lewis electron dot structures, we'll use them to show what the bonded atoms look like with one another. Dots are the symbols that just mean the number of electrons in there. Now, most atoms on the periodic table want to follow what's called the octet rule. That means that they want to end up having 8 dots around them in some way or another. A better way to describe it is to say that they want to have a noble gas configuration. And that's what brings up the duet rule, because obviously hydrogen doesn't want to get 8 or an octet of electron. It wants to get a duet of electrons to look like the noble gas helium. So atoms often gain or lose electrons to obtain 8, a noble gas configuration. Or hydrogen and helium, in their case, they have 2 electrons because they want to obtain a noble gas configuration of helium called a duet. And so the valence electrons, these dots right here, usually want to add up to 8 for most things, except for hydrogen. That once again explains why hydrogen only forms 1 bond with something, because it really also wants to share 1 electron with something else to get that full valence shell. So valence electrons, if you forgot what those are again, those are the S and P electrons from the highest energy level in an atom. And of course, this would be an example of an octet of electrons in something like neon, or maybe some ion that gained electrons to look like neon. And that would have a full 8 electrons right here, because 6 plus 2 is equal to 8. An example of a duet would be helium's electron configuration, 1s2, a full 2 electrons around it. So in this chapter on bonding, once again, we'll look at 3 kinds. Ionic bonding, to try to fulfill this valence electron idea of 8 or duet of 2. Covalent bonding, where we'll share electrons to make this happen. And then metallic bonding is not quite as concerned about that. It just wants to make sure that it has a lot of electrons to be very shared with everybody in its vicinity. More on bonding in a bit.